Hello and welcome. I am going to go over the metric system once again. I am going to go more in depth and give specific answers and examples to the worksheet as well. So please watch this video, look at the timestamps below to figure out exactly what point in this video you need to watch if you only need help with a certain topic. But if you're completely lost with everything, perfect. Watch this entire video. So before we actually start with the worksheet, I do want to go over again what the metric system is. And what the metric system is that it is a system of units that we use for specific measurements. And so for the metric system to measure length, we would use the base unit meter. To measure mass, we would use the base unit gram. To measure volume, we would use the base unit liter. And to measure temperature, we would use the base unit Celsius. And so the reason why I'm calling these base units is that because they are the basic units that we primarily use when measuring things of length, of mass, volume, and temperature. In the imperial system, like in the US and what they teach you in grade school, we learned that to measure length, we can use inches and feet and yards and miles. And it gets really confusing because there's so many different ways to measure length. But that's the beauty of the metric system. The only unit or the primary unit that we use to measure length is meter. The only thing that changes is the prefix that comes before these base units. And remember, I did go over this. Adding a prefix before the base unit will change the size of the base unit. So let's talk about those prefixes here. We've got kilo, hecto, deca, deci, centi, and milli. These are the prefixes that you can just attach before the base unit to change the size. And so what this worksheet is mainly about is to get you used to abbreviations, get you used to these prefixes, and get you used to unit conversions. So before I talk more about this slide, I do want to go over the prefixes. I think they are really important to know. You should be familiar with it before you move on to specific parts of this worksheet here. And so let's figure out how to write the abbreviations for these words. Okay, so I did do the examples for this one, and this one. And so how I did that is I would start with the prefix first. I need to figure out what the prefix I am working with is. So for this column right here, I know that the prefix is kilo, and the abbreviation for kilo is K. So all of these columns should start with a K. K. So easy as that. I have half of my abbreviation done, but I need to figure out exactly what goes next. What is the what is it called? What is the base unit? So for over here, I can see that this entire row, the base unit is going to be gram. It's going to be gram. And the abbreviation for gram is G. So then I would have to put G right there after the prefix. So then what do I put here? What is the base unit that is being shown here in this row? Well, the base unit is liter. And the abbreviation for liter is an uppercase L. So that's what I would then write there. So first things first, figure out the prefix and then figure out what the base unit is. And so side note, the whole uppercase and lowercase thing does matter when it comes to these prefixes and abbreviations. So most of these prefixes or most of these abbreviations are lowercase, except for liter. Liter is uppercase, and I'm not too sure why. Like, I'm sure there's a reason, but the reason isn't important. Just know that liter is uppercase. All right. So try out these other empty boxes by yourself. Remember, you just need to figure out what the prefix is and then the base unit. So let's move back to this slide here. And I do want to go over what it means to convert units. So converting units means that you are taking an amount of something in one unit and you are changing it to, let's say, another unit. And we have seen this in our daily lives. You've practiced converting from inches to feet, I'm sure, in your, grade school. You have practiced converting from cents to dollars in other classes as well, I am sure, in the past. And so now we are just doing the same method, the same idea of conversion, but using the metric system and its units. So it seems scary just because it's new words and everything, but the concept is still the same. So to figure out how to convert between two units, you need to watch this video right here. That's literally what the directions say. You need to watch the video or else you will not understand a single thing about this worksheet. You will not understand what I am talking about in this worksheet, and you will not get points for your lack of an answer here in this box. So please, if you have not done so already, pause this video right now and go ahead and click this link and watch it. The link is available in your own worksheet. You should be able to click and follow that link on your own worksheet. Watch that 4-minute video because it explains in detail how exactly you can convert between units. If this video still did not make sense, there is another video here. It's shorter and I feel like a little bit more clear once you get the basic ideas of what the first video talked about. So watch both of those videos. I do know that the second video link does not work for some people, so that is why I uploaded it onto Google Classroom. It's been uploaded since last week, so let me know if you just can't find it for some reason, but it is definitely on Google Classroom, the same place where you found this assignment. So watch those videos, answer this question, and we can move on. So basically the answer to this question is that you divide by 10 or you multiply by 10. That's how you convert between the units. But that's a lot of math and a lot of calculator work, right? So instead of actually having to do the math and divide or multiply, the easiest thing is just simply moving the decimal in your number based on the number of times that you jumped from unit to unit on this little chart right here. So next up right here, I'm going to talk about how to convert using that method I just described by just jumping your decimal around. And so something I do want to clarify first is that some people have noticed, okay, when I move to the right, I get smaller units. The units get smaller. But if it's getting smaller, then why am I multiplying by 10? I would think that multiplying means the number gets bigger. And so let me clarify that. Yes, the number gets bigger. The number gets bigger, but the unit is smaller. So if that's so confusing to you, let me try and put this into the context of money. If we have $1, that's supposed to be a decimal right there. We have $1 and we want to convert that into cents. We have $1, we want to convert that into cents. Hopefully you should know that there are 100 cents in $1. And that's what this table, what this chart here is trying to show you, that, whoopsies, let me do this, whoops, that the unit here, the unit for $1 is bigger than the unit for a cent, for a penny. We all know that pennies are worth really a tiny amount compared to $1. That's why it takes more pennies. It takes 100 pennies to equal just $1. So if that did not make sense, please replay this part of the video. That's pretty much it. The units get smaller. The units get smaller, but the number gets bigger because you need more cents to make up or to equal $1, just like how you need more centimeters to equal 1 meter. So now we are going to actually practice unit conversions using the problems that I have here. I have already done these problems here for you. I have the answer laid out nice and clear, but you may not understand how exactly I got that answer. So I'm going to show that right now. With the first problem being this, let's just pretend that I didn't give you the answer. First things first, what do you know? Looking at this problem here, what do you know? And what I know is my starting number. I know that I'm starting with the number 6, and I can also represent that by 6.0. That means the same thing as 6. I also know that I am starting with the unit kilometers. I'm starting with the unit kilometers, and I know that because it says it right here, 6 kilometers. So here's my starting point, kilometers. And I know that I'm going to convert that into centimeters. So I need to figure out where the prefix centi is, and aha, I found it right over here. Here is the prefix centi. This is where I want to end up. So I can take my pen, and so I don't think I've mentioned this yet, but the videos did. It would really help out if you actually have your own paper and pen on hand right now, and you actually wrote down these prefixes, and you are actually jumping around from prefix to prefix to figure out how to convert. Because if you were just sitting there watching my screen, not doing anything with your hands, you probably will not remember this as much. So if you do not have a paper and pen with you right now, pause this video, get some, and follow along with me on this video, so you can have a better idea of how to convert between units. All right, so I'm going to continue. Again, I have my starting point. You always want to start with your starting point, and you always want to make sure you know what your ending point is. So I'm starting with kilo, and I want to end on centi. I'm going to start at kilo, and I'm going to end at centi by jumping around. 1, 2, 3, 4, 5. You want to see that again? 1, 2, 3, 4, 5. One more time, just for good luck. 1, 2, 3, 4, 5. All right, so I know that I jumped to the right 5 times on this chart. That means I need to move my decimal 5 times to the right to convert to centimeters, to convert from kilometers to centimeters, or kilometers to centimeters. So let's do that. I have my decimal right here, my number. My starting number is 6. I'm going to jump 5 times to the right. Here we go. 1, 2, 3, 4, 5. That ending point right here is where my new decimal is going to be. So you're probably wondering, okay, Miss Catolico, but what do I do with all these empty spaces? What's the point of jumping the decimal around? The point is that you fill it in with zeros. You fill in these empty spaces with zeros. And this is your new number. All right, so let's tidy this up a little bit. We have we started off with 6.0 kilometers. And if we wanted to convert that into centimeters, the number that we got is the following. And I believe that's 600,000 centimeters. So now what we can do is double check our work here, check in with the answer that I had posted originally. Let's start with our starting number. We got 6 kilometers at the beginning. We had 6 kilometers. Then we jumped to the right 5 times. We jumped the decimal to the right 5 times to get this new number here, 600,000 centimeters. 600,000 centimeters. And all we did was just move the decimal. You don't need to actually change the value of the number. This 6 should always be there. There's either going to be more zeros or less zeros whenever you convert. Because remember, converting in the metric system, you are either multiplying or dividing by 10. You are either adding or removing zeros from the number. You should never be changing this 6 to a 7 or an 8 or something. And so let's go over another example here. This time with the base unit liter. Again, like before, let's try and forget what this number even was. Pretend that I didn't give you the answer right away. And so you always, again, want to start off with what you know. And what I know is that I start off with the number 1,130 milliliters. But I'm going to get rid of the milliliters for now so I can have my decimal seen here. That's my decimal. So let's figure out where I start on this chart right here. I have to start at milli. Milli is right over here. Here is the prefix milli, and I need to convert it. I can figure out what I'm converting it to by looking at this unit right there. I need to convert it to the unit liter. But all I see is kilo, hecto, deca, deci, centi. Where is liter? The reason why liter is not specifically written out there is because liter is a base unit. Most of the time, if the abbreviation only has one letter, like L, then you can probably tell that it is a base unit because there's no prefix that comes before it. So now I have determined my starting point here is milli, and I have determined that my ending point is here at the base unit. So I need to start at milli and jump over to where I need to go. 1, 2, 3. Try that again. Start at milli and jump to where I need to go. 1, 2, 3. So I moved 3 times to the left. I jumped over 3 times to the left. So what that means is this decimal right here, I need to move that 3 times to the left as well. The number of times that I jump on this chart should be the number of times that this decimal moves. Same with the direction. If I am moving to the left on this chart, the decimal should be moving to the left. If I were to jump to the right on the chart, then the decimal should be moving to the right. But in this case, I moved 3 times to the left. 1, 2, 3. So let's do that right now. Have this decimal, and I'm going to move 1, 2, 3. So my ending decimal should be right between the ones. So that looks really messy and ugly, so I'm going to rewrite it in a much neater way. We started off with 1,130 milliliters, and we converted that to liters. After we moved the decimal 3 times to the left, we got the number 1.130 liters. So let's double check our work. Erasing all this stuff right here. Let's double check if we have the correct answer. And I can see here that I started off with this number, 1,130 milliliters, 1,130 milliliters, and I can see that I was able to convert it to 1.130 liters. 1.130 liters. So again, the actual numbers are not changing. I should always have that 1. I should always have that 3 in my conversion. The only things that are changing is how many zeros there are and where the decimal is. In this case, the zeros stay the same. I just moved the decimal over here to the left. Here is our last example using the base unit gram. So again, I'm going to pretend I didn't just give you the answer. And we need to figure out what we know. What are we starting off with? Well, I can see that we are starting off with 3.9 grams. 3.9 grams. So I'm going to write that. 3.9 grams. So I need to look for the word gram, or I need to look at where grams is on this chart. However, I don't see it. I only see kilo, hecto, deca, deci, centi, and milli. But remember, gram is a base unit. You can also tell, again, because there's only one letter in the abbreviation, just a lowercase g. So here is grams. Grams is a base unit. Remember that your base units are either grams, meter, or liter. Anything with a prefix is not going to be here at the base unit. But I know that I am starting off with the base unit gram. I want to end up with the unit milligrams. So milli, aha, milli is right over here. There is milli. That is where I want to end up. So again, we're starting at the base unit here, and I'm going to count the number of times it takes, the number of jumps it takes to get to milli. 1, 2, 3. Try that again. 1, 2, 3. So I jumped 3 times to the right to get from the base unit to milli. That means I need to move the decimal in my number 3 times to the right in order to convert from the base unit to milli, or milligrams. So let's try that. We have the decimal here, and I know that I need to move that decimal 3 times to the right. So let's try that. 1, 2, 3. My new decimal is going to be over here where I ended my jumps, and I'm going to fill in the blanks with zeros. So if I were to rewrite this in a neater way, I would have 3.9 grams, because that's what I started off with. 3.9 grams is equal to 3,900 milligrams. So let's double check our answer. Erase all this here, erase all that there, and I can see that I started off with 3.9 grams. I can see that I started off with 3.9 grams, and I can see that I was able to convert it by jumping 3 times to the right and getting the number 3,900 milligrams. 3,900 milligrams. It's all just a matter of counting how many times you jump and which direction you are jumping in. So to recap, it really helps if you are doing this on a piece of paper, just like how they showed you in the videos. And if you have not watched the videos yet, please watch the videos, or else you're just going to be even more lost. But yeah, it really helps when you are using a pencil and a paper, so you can actually jump around like I have been doing here, and moving the decimal like I have been doing here.